5.6, number 356. We have a definite integral from 0 to pi on 4 of tan x. Now we don't have a specific rule that tells us that the antiderivative of tan x is something in particular, right? We can't think of a trigonometric derivative that produces tan x. So therefore, going backwards, we can't think of a trigonometric function that would be the direct antiderivative of tan x. But we can rewrite tan x as sine on cos, and it'll be very similar to the situation we had a moment ago, where again the derivative of one is the other, right? The derivative of sine is cos, the derivative of cos is negative sine. But again, if I were to choose u, right? If I choose u to be sine x, the derivative is cos x dx. I do not have cos x dx here. I have 1 over cos x dx. So I don't want to choose that one. So u should be cos x. That way when I take the derivative, I get negative sine x dx, and I'll just adjust this negative to the other side as always when I don't have it here. So negative du is equal to sine x dx. All right, so now we can replace the functions here. Sine x dx is du, and we've got 1 over u, but I need to compensate with this negative here, so I'll just put it on the outside. Now, I need to run the limits of integration because it's a definite integral through the transformation. Cos of 0 is 1. Cos of pi on 4 is root 2 on 2. That'll save me some work in the end. All right, so now we know this is going to be negative natural log of magnitude u evaluated 1 and root 2 on 2, according to the fundamental theorem of calculus. Part 2. So now we'll just substitute these in and try to write this in a concise way. We have negative on the outside of the whole thing. All right. I have natural log of magnitude root 2 on 2 minus, due to the fundamental theorem of calculus, part 2. Right. This negative is here. This negative is part of the fundamental theorem. Natural log of 1 magnitude. Now this can be written more concisely because, of course, these magnitudes on these positive numbers are doing nothing. We also know the natural log of 1 is 0, so that doesn't need to be written. So we now have negative ln root 2 on 2. But a negative on the outside of a natural log is the same as a negative 1 power on the input. So therefore I can rewrite this even as natural log of root 2 on 2 to the negative first, which would mean taking the reciprocal of the input. So 2 on root 2. The 2 on root 2 is just root 2, of course. So we get natural log of root 2 as our answer.